Oumuamua, the enigmatic interstellar object that captivated attention in late 2017 with its strange orbits, is once again grabbing headlines. This time, however, scientists are terrified. In a mere 2 weeks, Oumuamua is set to collide directly with Earth, an event that has never before been witnessed. What makes this cosmic occurrence particularly terrifying is not just the impending collision itself, but the alarming fact that Oumuamua shows no signs of decelerating. Are we facing a potential disaster? Join us as we delve into scientists' urgent warning about Oumuamua's direct impact to our planet. When you hear the term alien probes, what comes to mind? Perhaps it creates images from old sci-fi movies where extraterrestrial beings use strange instruments to examine humans. Or maybe you think of something like Oumuamua, a mysterious, cigar-shaped object that zipped past our solar system a few years back. In 2017, scientists like AVI Lab from Harvard University started talking about a different kind of probe, not the fictional kind, but the real possibility of space probes sent from distant civilizations. These probes would be like the ones we humans have sent out into space, such as Voyager and New Horizons. But the big question is, could Oumuamua be a similar probe, just from a different planet? AVI Lab, an expert in plasma physics, has even suggested that Oumuamua itself might have been an alien spacecraft. While that idea might sound far-fetched, it's got scientists buzzing with excitement. However, there are huge challenges. First off, the distances in space are mind-boggling. If aliens from the Andromeda Galaxy wanted to send a probe to Earth, it would have to travel an incredible 2.5 million light-years, that's 6 trillion miles per light-year. And then, there's the question of time. How do they make sure their probe gets here before their civilization collapses? But let's say they solve those problems. They'd still have to build a probe tough enough to withstand the harsh conditions of space, radiation, space debris, you name it. Think of it like building something super strong and tough, like a material that's as hard as a diamond but can also take a hit without breaking. Despite the challenges, the arrival of Oumuamua in 2017 got scientists buzzing with excitement. For decades, they've been waiting for an interstellar visitor just like it. And who knows? Maybe one day, we'll discover that we're not alone in the universe after all. Back in 2017, Thomas Zurbuchen, who was NASA's Science Associate Administrator at the time, announced an innovative discovery, the confirmation of interstellar objects like Oumuamua. This revelation sparked immense interest among astronomers worldwide. Then, just 2 years later, in August 2019, another interstellar object, 2I Borisov, was spotted. Unlike Oumuamua, Borisov had the typical features of a comet, sporting a distinct tail and coma. This mysterious visitor offered astronomers a rare glimpse into other planetary systems beyond our own. Initially appearing 10 times longer than it was wide, resembling a colossal cylinder, later observations revealed it to have a flatter, pancake-like shape. Similar shapes have been observed in other objects in the Kuiper belt, suggesting a commonality in their formation. By studying Oumuamua's brightness as it moved through space, astronomers deduced its dimensions and shape. Interestingly, Oumuamua's journey is traced back to a possible close encounter with 4 stars, with the red dwarf star HIP 3757 being its closest pass. This revelation left astronomers wondering about Oumuamua's origin. Did it originate from there, or has it been drifting through space for millions of years, its origins shrouded in mystery? The solar system is like a bustling neighborhood, with planets, asteroids, and comets all orbiting around the sun in tight loops. But in 2017, something extraordinary happened. An unusual traveler entered our cosmic neighborhood, named Oumuamua. Unlike the rest, its path wasn't a neat circle. Instead, it was hyperbolic, meaning it zoomed by the sun at a blazing speed, barely affected by its gravity. It was like a cosmic bullet whizzing through space. Oumuamua's presence was first noticed on October 19, 2017, by astronomer Rob Warwick from the University of Hawaii. At that time, it was already 21 million miles away from Earth, and it got as close as 15 million miles before continuing its journey away from our solar system. This interstellar visitor was moving incredibly fast, reaching speeds of 54.2 kilometers per second after getting a boost from the sun's gravity. But catching a glimpse of Oumuamua was no easy task. It was tiny and moved rapidly, giving us only a few weeks to study it up close. Luckily, the Hubble Space Telescope and other powerful observatories managed to capture some stunning images, revealing Oumuamua as a mere speck against the vastness of space. As Oumuamua speeds away, heading towards the constellation Pegasus, it fades from our view, disappearing into the depths of the Kuiper Belt, a region beyond Neptune filled with icy objects. But could it return? And what exactly was Oumuamua? Some speculate it might be an alien probe, while others think it's just a dead comet stripped of its gases over billions of years. One thing's for sure, Oumuamua's fleeting visit has left astronomers and space enthusiasts alike captivated, sparking debates and fueling our curiosity about the mysteries of the cosmos. However, Oumuamua's journey was not entirely straightforward. The Hubble Space Telescope noticed something peculiar as it moved away from the Sun, a non-gravitational acceleration. Typically, comets emit water vapor and dust, creating a tail that gives them an extra push. But Oumuamua didn't exhibit any signs of releasing water or other volatile substances commonly seen in comets. So, what could Oumuamua be? Unlocking the mysteries of Oumuamua. One popular theory suggests it's a chunk of nitrogen ice. According to researchers Alan Jackson and Stephen Desch from Arizona State University, Oumuamua might be a fragment blown off a Pluto-like object by a massive impact. If the nitrogen ice had melted due to the sun's heat, it would have provided the extra boost needed. However, Oumuamua would have to be smaller than initially thought to appear as pale as it did. Another theory proposes that cosmic rays interacting with surface ice in interstellar space freed hydrogen gas trapped in water molecules, creating a supply of hydrogen gas trapped in amorphous water ice. This theory, proposed by Darrell Seligman from Cornell University and Jennifer Brutner from Berkeley University, suggests that Oumuamua was warmed by the sun, allowing hydrogen to escape and altering the crystal structure of the ice, which seemingly propelled it forward. Additionally, astronomers Avi Loeb and Shmuel Bialy from Harvard University have suggested a rather interesting idea: Oumuamua could be a solar-powered spacecraft. According to them, the various peculiarities observed in this interstellar visitor could be satisfactorily explained by an artificial origin, hinting at the possibility of extraterrestrial technology at play. The path taken by Oumuamua suggests it originated from outside our local solar system. However, its true size and shape remain covered in mystery since we couldn't capture a detailed photograph of this visitor. Astronomers rely on its brightness and their knowledge of how asteroids and comets reflect light to estimate its size. Since no coma or tail has been observed around Oumuamua, some scientists doubt the comet theory. Outgassing, a typical feature of comets, would also change Oumuamua's rotation period, which hasn't been observed. These scientists also suggest that Oumuamua's apparent movement could be from the force that broke it free from its parent object, but repeated non-gravitational acceleration contradicts this. Instead, there's the fascinating theory involving sunlight. If Oumuamua is extremely thin, around 0.3 to 0.9 mm thick, its observed movement could be due to solar radiation pressure. They speculate that Oumuamua could be a light sail, a technology demonstrated in space missions like the Japanese Icaros probe and NASA's nanosail, D2. The calculations suggest that a light sail Oumuamua could endure a long journey through interstellar space. They estimate it could travel at least 16,000 light-years from its home system, wherever that may be. The idea that Oumuamua might be an alien spacecraft or space debris is taken seriously. It could have accidentally landed on Earth, or it might be a purposefully sent spacecraft examining our solar system. The unusual way Oumuamua was discovered adds weight to these possibilities. If it's part of a random population of objects, stumbling upon it as we did implies that every star in the Milky Way ejects an enormous number of such objects throughout its lifetime. However, our solar system doesn't produce as many Oumuamua-like objects. Additionally, Oumuamua's motion closely aligns with a region of the Milky Way galaxy called the local standard of rest, making it challenging to determine its origin. Conventional rockets won't catch up to Oumuamua as it heads towards the outer solar system. However, sending small robotic probes with sails hurtling towards it at high speeds could be feasible in the future, with projects like Breakthrough Starshot aiming for this. Whether we reach Oumuamua or not, studying its visit can prepare us for future encounters. By conducting thorough observations and learning from this experience, astronomers can better examine other intriguing objects currently in view. If the Oumuamua space probe were to return, it would prompt further considerations and preparations. Should we consider building a Karelian shipyard if we entertain the idea of something extraordinary happening? It's worth pondering what steps we should take if the asteroid space probe returns. To construct spacecraft capable of pursuing it, humanity needs a deeper understanding of dark energy in the cosmos. One suggestion is to send a craft after the asteroid probe, but the challenge is immense. Oumuamua is traveling at a hyperbolic excess velocity of $5.50 per year, putting it beyond Saturn's orbit within 2 years. This speed surpasses anything humanity has launched into space before. So, what kind of vessel would we need? And what propulsion method should we use, solar sails or perhaps something more exotic like a wormhole? However, the concept of wormholes poses significant challenges, including collapse, links to other universes, and the lack of construction knowledge. Cosmic gateways and interstellar travel. Back in 1935, Albert Einstein and Nathan Rosen introduced a fascinating concept of wormholes within the framework of general relativity. They proposed the existence of what they called Einstein-Rosen bridges, or wormholes, theoretical passages connecting different points in spacetime. These wormholes could potentially create shortcuts, reducing travel distance and time across the universe. Although Einstein's equations suggested the possibility of wormholes, none have been observed or confirmed to date. Some equations even hint at the presence of wormholes associated with black holes, but verifying this is challenging. Objects and beings entering black holes face an uncertain fate, making it impossible to determine if they connect to wormholes. At the heart of this concept lies Einstein's theory of spacetime, which he envisioned as a fabric encompassing the entire universe. According to Einstein, the interaction of mass and energy warps this fabric, creating valleys that influence the motion of celestial bodies like planets and stars. This manipulation of spacetime forms the basis for gravitational effects, rather than a direct force of gravity. Einstein speculated that spacetime could be manipulated further, even torn, giving rise to the idea of wormholes. The notion suggests that if a hole were opened in spacetime, there must be something on the other side. Surprisingly, Einstein and other scientists have proposed the existence of various types of wormholes, categorized based on their properties. Traversable wormholes are the most well-known and often depicted in science fiction. They serve as passageways between different points in the universe, enabling travel from one location to another, much like the wormhole in Star Trek Deep Space Nine. Non-traversable wormholes are inaccessible to travel. They may collapse before anything can pass through, or they lack an exit point, trapping anything that enters. The exploration of wormholes remains a captivating subject, blending theoretical physics with imaginative possibilities. While still largely speculative, the concept of wormholes continues to interest scientists and inspire creative works in literature and film. There's the intriguing notion of one-way wormholes, suggesting a journey through one end with another wormhole needed for return. Some of Einstein's equations hint at wormholes within black holes, though not passable. Conversely, white holes, opposite to black holes, expel matter forcefully. Two-way wormholes facilitate round-trip travel, while intra-universe wormholes connect points within our universe. Inter-universe wormholes, like those in DC Comics or Marvel, lead to alternate realities. The search for these cosmic shortcuts spans black holes, white holes, and celestial bodies, yet remains largely theoretical, akin to dark matter and dark energy mysteries. Einstein's theory of general relativity lays a mathematical foundation for wormhole existence, though interpretation and investigation continue. The allure of wormholes lies in their potential for interstellar travel, mirroring the epic voyages of Voyager and New Horizons spacecraft. While wormholes may be elusive, their possibilities fuel both scientific inquiry and imaginative exploration, reflecting humanity's ongoing quest for knowledge amidst the vast cosmos.